Good morning, College Algebra. This video is coming to you from the home of Mr. North. I even have Mrs. North sitting here with me today.
Hello.
I decided to make a little video for you for Section 5.3 since I'm not going to be there on Tuesday for Scholars Bowl. And I decided to go ahead and make a video of the whole thing just in case anybody does happen to check Google Classroom and wants to work ahead on this longer weekend. Congratulations to the guys for a great win last night. It was quite the nail biter, but you pulled it out. Good job. And on the home front here, Anna is officially dressed as a mermaid and off to school for her Halloween party. So I thought I'd start with a few mermaid jokes for you here today. It's pretty common for fishermen to meet mermaids. They meet online, of course. And I did hear mermaids prefer waterbeds, which makes sense. Yeah. They love their shell phones. And one last one. Let's see. Why did the mermaid cross the sea? No, nobody. To swim to the other tide. The other tide, of course. So anyway, moving on here. We're looking at Section 5.3 today. Today and I guess Monday and Tuesday. If you're watching this video, you're going to see the same kind of thing on Monday to start with. Logarithmic functions and graphs. So before we get into that, let's review let's talk about the inverses of exponential functions, because that's definitely related to logarithms. So I have here the red curve, which is the graph of the basic 2 to the x exponential function, right? We got the horizontal asymptote along the x-axis as a baseline going to the left, and we got the explosion upward on the right. And I have a series of horizontal lines, the purple, the blue, and the green, and that is representing the horizontal line test. And notice how the purple line only crosses once, the blue line only crosses once, the green line only crosses once. Any horizontal line is only going to cross once, so it passes the horizontal line test. And of course that means it's a what kind of function? Yes, I'm sure you're all saying it right now. A 1, 2, 1 function. And for us, that means it has not just an inverse, but an inverse function. Okay, even something that's not a function, you could come up with an inverse formula, as the book likes to call it, or an inverse equation, but that wouldn't always represent a function, as in the graph would pass the vertical line test. So this passes the horizontal line test, so the inverse will pass the vertical line test. So the inverse is also a function, and so we're going to look at the inverse of this exponential function 2 to the x on the next page. Okay, so the first part of your assignment, you're looking at some graphs. So let's start there. Okay, so if you think of it as a function machine, 2 to the x would take 0 as the exponent and apply that to the base 2, and 2 to the 0 would of course be 1, as any power of 0 is 1. Don't ask me about 0 to the power of 0. We're not going to worry about that. Okay, so here would be 0, 1, right? Okay, let's move on. 2 power of 1 would be just 2, right? Just one single 2, so it'd be on the coordinate wise, you'd have on the graph 1, 2. 2 squared would of course be 2 times 2, 4. So I'd have 2, 4. And then I'd have 2, let's go 2 to the third. 2 times 2 times 2 is 8. So 3 would go up to 8. So we'd start to see that upward trend really quickly there. And one more, 2 to the 4th. Wow, times 2 again, that's 16. So we're really jumping up quickly there. Okay, let's talk negative powers here. 2 to the negative 1. That's the reciprocal of 2 to the 1st, which is the reciprocal of 2, which would be 1/2. So at negative 1, the graph would be at 1/2. And 2 to the negative 2 would be the reciprocal of 2 squared, which was 4. So this would be 1/4, 1/4. So at negative 2, we're at 1/4. At negative 3, of course, the reciprocal of 2 cubed, which is 8, so that's 1/8. So negative 3 is at 1/8. And finally, 2 to the negative 4, as you already know, it's going to be 1/16. So that's negative 4 comma 1/16. So as we saw on the graph, as it goes to the left, it doesn't go, the negative x values don't make the graph go negative. They make it get closer and closer to 0. And that kind of levels out on that baseline of the x-axis. So now let's talk about the inverse. Remember, we know that that simply reverses the coordinates here. So instead of 0, 1, the inverse would have 1, 0. And 1, 2 would be 2, 1. 2, 4 would be 4, 2. And so on and so forth, all the way down the line. 8, 3. 16, 4, 1/2, and negative 1, 1/4, negative 2, 1/8, negative 3, and 1/16, negative 4. Okay, so let's look at that on the graph on the next page. Let's take a little peek at the graphs of those resulting functions here. So notice the red is y equals 2 to the x, and the blue is the inverse, which would be x equals 2 to the y. The x and y coordinates switched. And scroll up just a little bit. Notice you have the green line right there, which represents that y equals x line, which should be the line of symmetry between the original function and its inverse, and we definitely see that going on. The 2 to the x we knew had a horizontal asymptote of y equals 0. On the left, we already knew that, right? We saw that over here. Gets smaller and smaller, approaches the x-axis as a baseline. And then the inverse has a vertical asymptote of x equals 0 on its left side. So as the y values go down, the x values get closer to 0, right? As the blue curve goes downward on the left side, the x values get closer and closer to the y-axis, which gets them closer and closer to 0, right? So again, just the opposite, so to speak, of what happens with the exponential function. It does go up and to the right. They both go up to the right, but where the exponential goes up and explodes quickly up, the inverse gets further and further out as it goes up. So it kind of goes up at a slower and slower rate. Again, just the opposite. It does go up, but for every, to go up one more unit, it has to go out further and further each time. Okay, so let's talk about something on your assignment here. This is very similar to number 3. I'm not going to do number 3. You do number 3, but I'll do something like it here. So you have this kind of inverse equation. It's like an exponential, but the inverse. So it's got x equals 1/3 to the y. So the base is 1/3, and y is the exponent. So let's look at and they want us to do this by hand, it said. So let's do a point-by-point analysis like we did before. Okay, so I'm going to start with y values for the exponents and work out those powers for x. So, of course, if y is 0, the power is 0 is 1. So then the x would be 1. So that'd be 1, 0. 1, 0. So that's an x-intercept, not a y-intercept. Power of 1, 1/3 to the 1, that's just 1/3. So coordinates here, remember you start with x. So it would be 1/3, 1. So when the x is only 1/3, that's just a little bit right there. The y is 1. So it's up right there, something like that. Power of 2, 1/3 squared. 1/3 times 1/3, that's 1/9. So this would be 1/9, and 2. So that would just barely be past 0 on my graph and up to 2. So you see how it would be, it looks like it'd be trending. You'd have that vertical asymptote as it goes up on the left side. Okay. Let's do the negative exponents here. If it's 1/3 to the -1, that's the reciprocal of 1/3 to the 1. So that would be the reciprocal of 1/3, which would be 3/1, which is 3. So it'd be 3, -1. 1, 2, 3, -1 right there. And 1/3 to the -2 would be the reciprocal of 1/9, which would be 9. Right, so it'd be 9, -2. So all the way over to 9, and then -2 right there. So it goes out and to the right. It's just upside down from the one we just looked at, kind of. Still has the vertical axis on the vertical asymptote as the y-axis on the left. Still goes out to the right, but it's upside down. So no surprise, because again, we saw that on the last section. This would be the same thing as 3 to the negative y, like that. So it's the vertical reflection of 3 to the y. Okay, that's just extra information. You don't have to know that, but your graph on number 3 is going to look pretty similar to that. Okay, let's finish out the talk of graphing here with this question. So how would we take this inverse equation where we took y equals 2 to the x and we interchanged x and y. Now it's x equals 2 to the y. That's the inverse. To solve for y, that'd be kind of tricky. You'd have to find the power y on the base 2 that would result in x. The name for that is a logarithm. To figure that out, you need a logarithm. Okay, so that's where the logarithmic function comes from. These are functions, exactly like the one shown at the top of the page, where the output y is the exponent. The output is the exponent. Okay, the output is the exponent. The input is the resulting power, the result of the power of y. The input is the result of the power of y, right? Just like we did when we set up that table. I used the the y was the exponent. That was the, I was using y as the exponent, and x was the result of that power. Okay, so that's what a logarithm function does. So where 2 to the x would take a power of 0 and put that on a, that make that the exponent of 2. 2 to the power of 0 is 1. The inverse, which would be log with the base of 2 of x, would say for the input, 1 would be the result of what power on 2? 0. So the output is the exponent, right? The 0 is the exponent. 1's the result of the power. Okay, so we write that, of course, like this. You can see y equals log base 2. The base is 2, right? Just like up here. Y is the exponent. X is the result. Okay. So let me show that another way. Because we're going to be doing this a lot here coming up in the lesson. It'd be the same thing as saying, if you take the base 2 raised to the power y equals the x. And of course, that's exactly what you have right there. 2 to the y equals x. That's what a logarithm equation represents. Okay, it's the inverse of y equals 2 to the x. So, number 5. When we see just what I have up there, y equals log base 2 of x, we're thinking of 2 with an exponent of y equals x. So I'm going to do exactly what we did earlier. I'm going to use exponents for y and see what the result of that is, and that's going to be my x. So 2 to the 0 is 1. So I'd have 1 comma 0. X-intercept right there again. 2 to the 1 is just 2. 2 comma 1. Over 2 up 1. 2 to the second is 4. So I'd have 4 comma 2. And I probably could even fit one more on there if I wanted to, but we'll keep moving. 2 to the negative 1, that's the reciprocal 1/2. 1/2 negative 1. Over 1/2 down 1 right there. And 2 to the negative 2 would be the reciprocal 1/4. 1/4, whoops. And 1/4 and negative 2. So over 1/4 and down 2, something like that. So again, you see what we said earlier, this vertical asymptote, kind of a side line here on the left side of the y-axis, and upward as we go to the right. And I probably could even figure out that it's going to be 8 and 3. Something like that. Okay, so 3 and 5, that's pretty much what you're doing, looking at the graphs of those. Inverse, which are logarithmic type functions. It said you can check this on a calculator. So here's what I typed in. To do log base 2, I will say you have to have the newer operating system to do that. If you have that, you can find out by pushing the math button. It's right under alpha. Is there an alpha button? And then you'll have the math button right under that. And it'll bring this menu up, and you got to scroll all the way down towards the bottom, and log base allows you to designate any base you want. Now, only the newer ones would have that setup in order to use like a base of 2. Okay, if you don't have that, what you can do to do it on your calculator, we'll talk more about this later, but there's a formula that says if I did, for instance, let's say I was going to try to graph log base 2 of x, and I don't have the log base function here. What you can do is you have there's a log button on the left side of your calculator, and just use that, just a regular log. We'll talk more about that here in a minute. And just do log of x, okay, and then divide that by log of 2. And that will do the same thing. That would be the same as log base 2 of x. And we're going to talk about why later in the lesson. Okay, so that should show the graph just like what we said there. It's 1, 0, 2, 1, 4, 2, and so on and so forth, 8, 3, okay, 1/2, -1, 1/4, and so on. There's your graph. Okay, and you could trace to double check the coordinates. You could use your table to double check the coordinates if you wanted to. Okay. So I think that completes the graphing section of the lesson. So I'm going to stop the video there and make a new one for the next part. And if you get to that point, you can watch it. Okay, so I'm going to stop for now. If you got this far, good job. Have a great day, and I'll see you in the next video. Bye-bye.